NASA's spacecraft just detected something on Europa that breaks every rule we know about frozen moons. Water shooting 200 kilometers into space. But that's not the impossible part. What they found in that water changes everything. Europa is Jupiter's fourth largest moon. Scientists had studied it for decades. It looks dead, frozen, a ball of ice floating in the void. But that ice hides something. Under the surface, miles below the cracks and frozen plains, there's an ocean, a liquid ocean, and it's massive. This ocean contains twice as much water as all of Earth's oceans combined. Twice. But it's not just sitting there frozen. It's liquid. It moves. It has currents. For years, scientists had one question. How? Europa is 5 times farther from the sun than Earth. The surface temperature is minus 160 degrees Celsius. Everything should be frozen solid. Then in 2013, Hubble spotted something strange. Water plumes shooting from Europa's surface into space. This wasn't supposed to happen. The ocean wasn't locked away. It was erupting, breaking through the ice. Something down there was heating the water. Something powerful. October 14, 2024, NASA launches Europa Clipper, the largest spacecraft ever built for a planetary mission. Its target, Europa's hidden ocean. The mission is simple. Fly through the water plumes, capture samples, analyze them, find out what's in that ocean. The spacecraft carries 9 instruments, each one designed to detect one thing: signs of life. 3 weeks ago, Clipper completed its first flyby. It passed just 25 kilometers above Europa's surface, right through a water plume. The instruments activated, they collected data, and they sent it back to Earth. When scientists analyzed the results, they found something they didn't expect. The water plumes contain organic molecules, carbon-based compounds, the building blocks of life. But these aren't simple molecules. They're complex. Amino acids, lipids, compounds that on Earth only form in the presence of life, or in environments where life could exist. Here's the problem. Complex organic molecules need energy to form. They need heat, chemical reactions, active processes. You can't make them in frozen water. It's chemically impossible. Europa's core is dead. No volcanic activity, no radioactive decay, no internal heat source like Earth has. According to everything we know, this moon should be frozen all the way through. So where is the energy coming from? The answer is 390 million miles away. Jupiter. Every 3.5 days, Europa completes one orbit around Jupiter. And Jupiter is massive. Its gravity is 2.5 times stronger than Earth's. That gravity pulls on Europa constantly. As Europa orbits, Jupiter's gravity stretches it, squeezes it, pulls it into an oval shape, then releases it, then squeezes again, over and over, billions of times. Imagine squeezing a rubber ball in your hand over and over. Eventually, it gets warm. That's friction. That's what's happening to Europa, except on a planetary scale. This process is called tidal heating, and it generates enough energy to keep Europa's ocean liquid for billions of years. But the new data shows something more. The ocean floor has hydrothermal vents, underwater volcanoes, cracks in the rocky core where superheated water erupts, just like the ones we have on Earth. On Earth, these vents are covered in life, bacteria that feed on chemicals, tube worms, crabs, entire ecosystems that don't need sunlight. They survive on chemical energy alone. Europa has the same setup. Liquid water, organic molecules, energy from hydrothermal vents, and something else. Salt. Clipper detected sodium chloride, table salt, and magnesium sulfate. These salts come from rocks. They dissolve in water. They create chemistry, the same chemistry that powers life on Earth. Think about what this means. 4 billion years ago, Earth's oceans looked like Europa's ocean today. Dark, deep, covered in ice. No sunlight, just chemistry and heat. And in those conditions, life began. Not on the surface, not in sunlight, in the deep ocean, at hydrothermal vents, where water and rock and heat mix together. If it happened here, why not on Europa? same water, same chemistry, same energy source. The only difference is location. If it happened here, why not on Europa? Same water, same chemistry, same energy source. The only difference is location. If life exists on Europa, it means life isn't rare. It means every ocean world could have life, dozens of them, right here in our solar system. Europa Clipper will make 49 flybys over the next 4 years. Each one will pass through different plumes. Each one will collect more data, more evidence. The next closed flyby is scheduled for March 2025. The spacecraft will pass just 16 kilometers above the surface, the closest pass ever, and it will aim for the most active plume zone. By the end of 2025, we'll have our answer. Is there life in Europa's ocean? The most important discovery in human history is 390 million miles away, and we're about to find it.